I got involved in it because the first distortion I noticed was that it was socially regressive. It was essentially, as one of my colleagues at Harvard said, I don't know how this translates into Portuguese, solar panels became bling for the rich. Bling is like jewelry, expensive things you don't need, but rich people like to have it. And the people who paid for it were lower income people because they couldn't afford it or they didn't live in housing. So it was socially regressive. That's how I got interested in the issue, because I was interested in trying to get regressive things out of electric tariffs. But then beyond it, it had several other flaws that came out. Number one, you're paying somebody for delivering a fully bundled retail electricity product, which means the energy, it means the capacity, or the capacity value, and also it meant the reflecting all the costs of delivering energy, the wires, the labor. Well, they don't do any of those things. What they deliver is energy, and they do it on an unpredictable basis. And in the U.S., it's not quite the same. The situation in Brazil is a little different. In the U.S., solar is always off-peak. Peak in the United States is more or less around jantar. So when people come home at 6 o'clock at night and they turn on their air conditioning or they turn on their heating or they turn on their television and they start cooking, that's when the peak is. How much solar is produced at peak? Zero. So when the prices are the highest in the marketplace, and when you most need the energy, and from an environmental standpoint, you want to dispatch cleaner plants. But the further you go down the merit order of dispatch, so you're getting to more expensive plants, you're getting to dirtier, more polluting plants. So at the time you want to reduce pollution because the demand to use the dirtiest plants is there's no solar. So you don't even get that much environmental benefit, and arguably you don't get any you could have actually the opposite effect of actually resulting in more carbon. They don't produce carbon, but results in more carbon. So there were a lot of mythology grew up around solar energy that wasn't true. And people assume, well, in the mid-afternoon when it's hot and it's sunny and people really, everybody's got their air conditioning on, that's when the peak. That's not when the peak is, because nobody's home. The peak comes later. And also in the US, if you had storage, then that would be fine. Then you could simply store and you could sell to the system when it needs it. But there is no storage. Now in Brazil it's a little different because you have the reservoirs. So you have some storage, so the economics is a little bit different in Brazil. Although over time you're going to have less storage just because it's environmentally difficult to build the reservoirs. But in the U.S. we don't have that. I mean, we have some storage, but not much, not like Brazil. So what happened? But the way that the incentives were for rooftop solar, why would you do that? Why would you install smart inverters? Smart inverters would enable you to actually enhance the operations of the system, or storage, which would allow you to to produce energy, and not produce it, but actually have it available at peak demand, or have panels that shifted and followed the sun. So that way, instead of solar, basically in the U.S. generates between, say, 11 in the morning till 4 in the afternoon. If you had panels that followed the sun, you could probably extend it until, 5 o'clock, 6 o'clock, but certainly further into the day and move into the peak. But there's no incentive to do any of those things because the incentive is to produce the most kilowatt hours regardless of when you produce them. And that's because of the way net metering works. It's a perverse incentive, because if you were developing from a perfect economic order, what you do is you would pay the highest price when the demand is the highest. This how it works exactly. Not only does it work in the opposite way, the incentives are to encourage you not to produce when the system needs it, and not to invest in things that would make the system more efficient. For example, it is theoretically possible that proper location of solar panels could actually improve the operations of a distribution company. But we don't plan them. They go wherever we ever have a buyer, that's where they go. So there's no way to know where they're going to go. And there's no, if you're not paying market prices, why would I ever invest in storage and batteries? Why would I ever invest in smart inverters? I wouldn't do any of those things. So the problem is, what's really interesting about it, and there was a study that MIT did a few years ago that points it out, is net metering actually in the long term is harmful to solar technology. Why? Because it makes it less, there's no incentive to be sustainable. There's no incentive to be efficient. The incentive is to do exactly the opposite. So when you put all these things together, it becomes fairly clear that net metering is a problem. Now it's interesting because a lot of the solar people, well, that's what the fossil fuel industry says, and that's what the utilities say because it eats into their profits. And the fossil industry is divided, and actually a lot of the solar companies, investors, are in the fossil business too. A lot of the oil companies are in the solar business as well. But the other thing it does is the utilities it doesn't make any difference to the utilities. I mean, it does in a theoretical way, but in a financial way it doesn't. They're going to get their money. The only question is who pays the money. And so what this is if you ask yourself, as I said earlier, who can afford solar panels, that cost, any $20,000, $25,000, $30,000 to put on your rooftop. And then you need a good house with a strong roof, and you need to own that house, not rent that house. So who does that mean? You pretty much define lower income people out of any benefits, but they're the ones that get to pick up the costs. And what are the costs that they're cross-subsidizing? One, it's paying for a full capacity for an intermittent product. When I was a regulator, if a utility came to me and said, we're going to sign a capacity contract to have the energy capacity from a solar unit that produces 6 hours a day if the sun is shining, are you crazy? Why would you do that? The only reason to pay for capacity is so it's there when you need it. If you don't know if it's there when you need it, why would you pay for that? But they get capacity payments as if they were available. Secondly, they get, I mentioned earlier, they're getting paid for the full delivery of the product when in fact they don't do that. The other problem is when they do generate, whether they're using it for themselves or whether they're selling it to the system, when they do that, they're not paying any of the fixed costs of the system. But they use the system 24/7. They use it as either backup or their battery, the system, or they use it to export energy, or they use it to import energy. But they're always using it. But when they're producing energy, they don't pay for any of it. Well, what does that mean? Who does pay for it? Everybody else. So it's a very inefficient cross-subsidy, which runs against sort of the fundamental principle of energy pricing, which is the person that causes the costs ought to pay for it. And now we're shifting those costs to other people who didn't cause them to be incurred, and we're relieving some people of the obligation to pay for something that they caused the system to incur. So the problem, so that's kind of what the problems are with net metering.